So today we're going to talk about the story behind a temperature scale a lot of us use every single day. And more importantly, the pretty unlikely scientist who brought some much-needed order to the total chaos of measuring heat and cold, a guy named Daniel Gabriel Fahrenheit. Okay, just for a second, I want you to imagine a world with no reliable way to measure temperature. Seriously. No weather forecasts, no setting your oven to 350, no quick and easy way to know if you've got a fever. It sounds like a mess, right? Well, that was pretty much reality before one guy decided to fix it. So let's set the scene. Before Fahrenheit came along, trying to measure temperature was, well, it was basically the Wild West. Scientists and everyone else had to rely on really vague words like warm or freezing because there was just no universal standard to work with. I mean, sure, they had thermometers, but they were all over the place, totally unreliable. Different people were using different liquids, different scales. It was a complete free-for-all. What one thermometer in Paris called warm might read as hot on another one in London, even if they were in the exact same room. It was pretty much just scientific guesswork. So who was the hero that swooped in to solve this problem? Well, it wasn't some famous professor or a well-known philosopher. Nope, it was the son of a merchant, a guy whose life took a really tragic and completely unexpected turn towards science. See, Daniel Fahrenheit was born way back in 1686, and he seemed totally destined for a life in business. But when he was just 15, his entire life was turned upside down. His parents tragically died after eating poisonous mushrooms. Awful, right? He was sent off to Amsterdam to become a merchant, but you know what? He just couldn't shake his real passion for science. And eventually, he just ditched his apprenticeship to go chase his curiosity. And it was that curiosity that led him to tackle one of the biggest scientific puzzles of his time. How do you measure temperature accurately and reliably every single time? His whole quest for order started with one key innovation. His first big move was all about what was inside the thermometer. Instead of using alcohol, which was what pretty much everyone was doing, Fahrenheit was a pioneer in using mercury. Why mercury? Because it expands and contracts with this incredible, predictable consistency. That one change made his thermometers way, way more precise than anything else out there. Okay, so now he's got this super reliable tool. That's great. But what good is it if the numbers on the side don't mean the same thing everywhere? He knew he needed fixed points, reference points that any scientist anywhere in the world could create and use to calibrate their own device. So his first anchor point, his zero, where did that come from? Well, it was literally the coldest temperature he could reliably create in his lab. He made this freezing cold, slushy mixture of ice, water, and salt. And that became 0 degrees Fahrenheit. Next up, he needed another fixed point that everyone could agree on. The answer? Simple. The temperature at which plain old water freezes. He marked that spot on his scale as 32 degrees. And to complete the puzzle, he needed one more anchor point at the other end of the spectrum. You probably guessed it, the boiling point of water. He set that at 212 degrees, so there you have it. With 0, 32, and 212, his scale was born. Now, the real genius of this system, at least for the time, was its precision. By putting 180 degrees between the freezing and boiling points of water, he created this really granular scale. It lets scientists measure tiny little changes in temperature with amazing accuracy without having to mess around with fractions or decimals. But of course, Fahrenheit wasn't the only game in town. His system wasn't the only one out there. Which brings us to the big showdown, the battle of the scales, and his main rival, a guy named Anders Celsius. So a few years later, the Celsius scale comes along, and it offered a system that was, well, a lot simpler. 0 for freezing, 100 for boiling. Nice, clean, round numbers. And because of that beautiful simplicity and the fact that it lined up perfectly with the metric system, most of the world eventually adopted Celsius. So that begs the question, why on earth does Fahrenheit still stick around, especially in the United States? Well, a big part of it is how useful it is for describing the weather as we humans actually feel it. Because the degrees are smaller and more granular, a 5-degree change from, say, 70 to 75 Fahrenheit feels more specific than the same change in Celsius. It's kind of built for the human experience. But you know, Fahrenheit's impact is so much bigger than just a number on your weather app. His scientific work was absolutely foundational. For instance, did you know he was the first person to actually document the phenomenon of supercooling? That's this wild thing where water can stay liquid even when it's below its normal freezing point. His super meticulous experiments also helped lay the groundwork for what would eventually become the entire field of thermodynamics. His work was so important that he was even inducted into London's prestigious Royal Society. So, the next time you hear the weather report is 72 degrees, or you preheat your oven to 350, just take a second to remember. You're using a system that was born from an orphaned merchant's son who just refused to accept guesswork and dedicated his life to creating precision. It's pretty amazing when you think about it. Daniel Fahrenheit basically gave us a language to understand the invisible forces that shape our world. And it just makes you wonder, what other everyday things that we completely take for granted have their own hidden, fascinating stories just waiting to be explained?